Welcome to Unit 5, Lesson 9. Today we want to look at real-world applications of slope-intercept form. In other words, where would we see slope-intercept form out in the real world? Before we begin, let's quickly review slope-intercept form, slope, and y-intercept. If you'll recall, slope-intercept form looks like y equals mx plus b. In that form, m is the slope and b is our y-intercept. The slope of an equation is the rate of change. Okay, the slope looks at how do our y values change versus how do our x values change. Finally, our y-intercept, remember, is a constant. It is the number without a variable. When we look at our y-intercept, recall that that is the value of y when our x value is equal to 0. Okay, that's going to be important in a few minutes. All right, so let's look at our first real-world example. Carrie Auto Shop has a standard $12 shop charge for every job that it takes. Okay, what does that mean? It means no matter how big or how small the job might be, they are going to charge a $12 fee. In addition, the mechanic that actually works on the job is going to charge $20 per hour for labor. Our first question is which number in that problem represents the slope and how do we know? Remember, the slope has a variable with it. That variable changes value. And when the variable changes value, so does the value of this term. So the slope in this expression is going to be the number that changes value depending on the number of hours that the mechanic works. So in this case, the $20 is our slope because that value varies depending on the number of hours the mechanic works. If the mechanic works for 1 hour, then our fee is going to be $20. But if the mechanic works for 2 hours, the fee for his portion of the job would be $40. Or 3 hours, his fee would be $60. Which number in the problem represents the y-intercept in y? Remember that our y-intercept is a constant. So which number is going to stay constant despite the number of hours worked? If you said $12, you are correct there. The $12 is constant. That value stays the same no matter how many hours the mechanic works. If the mechanic works on the job for 2 hours, that $12 fee is still in place. If the mechanic works for 10 hours, the $12 fee is still in place. The third question asks us to write an equation to model the relationship between the time that is spent on a job and the total charge for the job. When we think about this equation, we want to write that in slope-intercept form. Y equals my slope, which is 20, times x, plus my y-intercept, which is 12. When writing the equation of the relationship, you want to make sure that you identify your variables. In this example, the y is going to represent the total cost of the job. The x is going to represent the number of hours that the mechanic works on the job. Okay, so another way we could write this is that the cost is equal to 20 times the number of hours plus another $12. Okay, that's still in slope-intercept form. Part D says that Joshua is a mechanic at the Carrie Auto Shop. He spent 2.5 hours servicing a car. How much will the customer be charged for this job that Joshua did? In this case, we were told the number of hours that Joshua worked on the car. Remember that x represents the number of hours. So we will plug 2.5 in for x. So the cost that we're going to pay is going to equal 20 times 2.5 plus the $12 shop fee. The total that we're going to end up paying there when we do 20 times 2.5 plus 12 is $62 for Joshua. Part E says that Carrie Auto Shop charges $47 for a job. How much time did the mechanic work on this job? The question tells us that we were charged $47. It also says how much time did the mechanic spend on the job. This indicates that we don't know how long the mechanic worked. In this case, we don't know the X value, but we do know that we spent $47. Rewriting our equation, the cost of 47 is equal to 20 times the number of hours plus 12. If we subtract 12 and then divide by 20, we find that X is equal to 1.75 hours. So the mechanic worked on that job for 1.75 hours. Finally, part F says, remember that the y-intercept is the value of X, occurs when the value of X is 0. According to our model, that means that Carrie Auto Shop is charging $12 for 0 hours of labor. Remember, it is the cost when the number of hours is 0. So if I plug a 0 in here, 20 times 0 is 0 plus 12. So that means for 0 hours of work, Carrie Auto Shop is doing $12 worth of work, but they've worked for 0 hours. Are they ripping us off? Think about that for a second. You may have to think outside the box on this one. The answer is no, they're not ripping you off. That $12 fee is some sort of diagnostic fee. They're charging you a small fee to diagnose but not fix the problem. If they came to me and said something like my battery is dead, I might choose to fix that myself. They shouldn't work for free for that. They've done a job. They've diagnosed the problem. I will then go fix it on my own. They should be compensated for that. So that $12 fee is a fee for them to diagnose but not necessarily fix the problem. If I say change my battery, they will then charge me $20 per hour to do that. The $12 simply comes from determining what the problem was, but not yet fixing it. All right, in our next example, in order to curve the final exam in biology, a teacher uses the equation G, grade, equals 2.5 P plus 10. In this case, G is the curved test score, or the student's grade, and P is the number of problems that the student answers correctly. The first question is, how many extra points does each student receive on their test? So regardless of how many questions or the number of problems the student answers correctly, how many extra points will the students receive? Well, if we're thinking about how many points they're going to get regardless of the number of questions that they answered correctly, then we're talking about the y-intercept here. We're talking about the constant, or the thing that doesn't change no matter how many questions we answer correctly. So in this case, the students are going to earn 10 points. Y-intercept is 10. The next question asks us how many points is each correct problem worth? Okay. Well, remember that the number of correct problems the student answers correctly was the value of P. That means that whatever I multiply by P is going to be the number of points that students get for each correct problem. So the answer here is that students get 2.5 points for every problem they correctly answer. Okay. Part C. What grade would you expect a student who correctly answered 25 questions to make? All right, we've been given a value of 25 questions. We need to decide whether that is going to go in for G or for P. Right? Remember, G represents the curved test score. 25 wasn't our curved test score. 25 was the number of questions the student answered correctly. P is the number of problems the student answers correctly. So 25 should be put in place of P. So G is equal to 2.5 times 25 plus 10. When we answer that question, the student's grade should be 72.5. Part D says, how many questions would a student need to answer to make a 100 on the exam? In this case, we know the grade on the exam needs to be 100, so we've been told the value of G. The question says, how many questions? That's a question there. How many questions would a student need in order to make a 100? So in other words, how many questions P do we need to correctly answer for our grade to be a 100? So plugging in a 100 for G, 100 equals 2.5P plus 10, right? When we subtract 10 on both sides, and divide by 2.5, we should find that P is equal to 36. Okay. In other words, the student needs to correctly answer 36 questions in order to make a 100 on the exam. Okay. The third example says that to save for a car when he turns 16, Sam is going to begin a savings plan. His savings are described by the equation S for savings is equal to 50W plus 560. S represents Sam's total savings in dollars, and W represents the number of weeks that he's been saving since the start of his savings plan. The question starts with how much money has Sam already saved when he started the savings plan. So regardless of the number of weeks that's passed, how much money did Sam have in the account to begin with? So whether the number of weeks were 1 or 0 or 30, how much money did Sam already have in the account? Right? So this is leaning towards our y-intercept, or the amount that doesn't change no matter how many weeks Sam is on the savings plan. In this case, Sam had already saved $560 when he began the savings plan. How much money does Sam save each week? All right, that is talking about our slope. Keyword there being each or per week. And so each week, according to this equation, our slope is 50. Sam saves $50 each week. The last question asks us how much money does Sam have at the end of 52 weeks? In this case, we know the value of W. We are being asked how much money does Sam have? In other words, how much savings? So we are looking for S if we know that the number of weeks that Sam has saved is equal to 52. When we plug that in and solve, 52 times 50 plus 560 means that Sam has saved $3,160 in 52 weeks. All right, a couple more questions here. Number 4 says that Movies Now is an online movie retailer that allows its members to stream recently released movies, very similar to, say, Amazon Prime or Netflix. There's an annual membership fee of $28.98, and the average price to stream a movie is $3.99. We want to write an equation that will model the approximate amount of money Y that a member is likely to spend to stream a given number of movies X over 1 year's time. Again, today we're concentrating on slope-intercept form. Right? So we need to be able to identify a slope and a y-intercept here. The first number provided in my problem is $28.98, and I am told that that is the annual membership fee. That fee is going to be in place regardless of how much money how many movies I decide to stream. If I stream one movie, I'm still going to pay the $28.98 membership fee. If I stream 500 movies, I'm still going to pay the $28.98 membership fee. So this $28.98 is my y-intercept, or the value of B. The average price to stream a movie is $3.99. It is $3.99 per movie that I decide to stream. We are now ready to write our equation. The amount of money Y a member is likely to spend streaming is equal to 3.99 times the number of movies they stream plus their $28.98 fee for membership. Make sure that you identify your variables. In this case, the Y is the total cost, and the X is the number of movies that are being streamed. Number 5, North Carolina Brick Company determines the cost of a load of bricks by considering the number of bricks that are going to be delivered. The equation C is equal to 0.38B plus 30, notice that's in slope-intercept form, is going to be used to estimate the cost to deliver B bricks. So C is the cost and B is the number of bricks. The first question says that using the equation, determine how much it would cost Mr. Jones to have 500 bricks delivered to his home. We know Mr. Jones is going to have 500 bricks delivered, so 500 is going to be put in place of B. The cost is equal to 0.38 times 500 plus 30. When I multiply that out, Mr. Jones is going to spend $220. Part B says, what do you think the slope of 0.38 represents? Make sure that you use context from the problem. What is that 0.38 or that 38 cents representing? If you said that it is the cost per brick, you are correct. Mr. Jones is paying 38 cents for every brick that he has delivered. Part C says, remembering that your y-intercept occurs when the value of x is 0, what does the $30 in the equation represent? Well, if you recall, x is the number of bricks. If the number of bricks is 0, 0.38 times 0 is 0, but we still have this plus 30. That would mean it would cost me $30 to deliver 0 bricks to my house. Well, that doesn't make sense. We wouldn't really pay this $30 unless we were actually delivering bricks. But what does that $30 in the equation represent? If you said it is the cost to deliver the bricks, so like a delivery fee, then you are correct. So it is the cost for 0 bricks, and we would only pay it if we were actually having bricks delivered. So that $30 is a delivery fee that is built in. Our last example says, I'm sorry, that's not our last one. We have a multiple choice question here. In professional basketball, y equals 0.73x minus 22. This describes the relationship between rebounds made x and free throws attempted y. The slope of the equation indicates which of the following. So our slope here is equal to 0.73. If we take that and convert it into a fraction, that means we have 73 out of 100. If you'll recall, slope is the change in y over the corresponding change in x. We're told in our problem that y represents free throws attempted, and the x represents the rebounds made. Okay, so for every 73 free throws that are attempted, 100 rebounds are made, is what this would say. For every 73 free throws attempted, there are 100 rebounds that are made. All right, our final example, with your partner, create a real-world problem that can be modeled using the linear equation.